All right, lesson 1, solving equations using addition or subtraction. So the first couple equations we're looking at here, you can almost just look at the blank and figure out what it has to be. So what plus 4 equals 5? Well, that has to be 1. In the next example, something minus 6 equals 2. Well, if we have 8 and we subtract 6, that'll give us 2. In the next example, we have something plus 6 gives us negative 2. Well, if you get a little number line, our final answer needs to be at negative 2, and we're adding 6. So we have to start at negative 8. 7 minus something gives us 10. Well, if we're subtracting something, but we're getting more, this has to be a negative as well. So that's going to be negative 3, because really that's like 7 plus 3 is equal to 10. Well, we can come up with some rules to solve equations, and in order to solve an equation or eliminate a variable, we're going to do the opposite or inverse operation. So in this first example, x minus 6 equals 10, we're actually going to add 6 to each side. That makes a zero pair, and we get x equals 16. And to check it, you start with your original equation, but substitute in your solution. So does 16 minus 6 equal 10? And yes, it does. The next example, we are adding a negative 4, which is the same as subtracting 4. So the inverse operation of subtraction is addition. So add 4 to each side. That makes a zero pair, and y equals 13. And to do your check, 13 plus a negative 4, does that equal 9? And indeed it does. We have negative 16 plus z equals 7. So in order to make a zero pair, we're going to add 16 to each side. That makes a zero pair, and we get z is equal to 23. To do our check, negative 16 plus 23, does that equal 7? And indeed it does. X plus 3 equals 17, so the inverse operation is to subtract 3. That makes a zero pair, and we get x is equal to 14. And to do our check, 14 plus 3, does that equal 17? And yes, it does. 13 plus y equals 20, so we want to get rid of the 13. So the opposite operation is to subtract 13, and you get y is equal to 7. And to do your check, 13 plus 7, that does equal 20. Z minus a negative 5 equals negative 13. So really this is z plus 5, gives me negative 13. So if I subtract 5, which is the inverse operation, I'm going to get z equals negative 18. And to do the check, negative 18 minus a negative 5 equals negative 13. That becomes negative 18 plus 5. And the left side equals the right side, so we are good to go. So if you try these, pause the video, and then come back and see if you've done them correctly. Make sure you do your check and see how you do. Okay, so if we subtract 4 here, we're going to get x equals negative 14. And to do your check, negative 14 plus 4 equals negative 10. Negative 10 does equal negative 10. This really is y plus 9 equals 4. So if you subtract 9, y equals negative 5. So negative 5 minus a negative 9 is really negative 5 plus 9, and that works out. Here we have 12, so we need to subtract 12. And we're going to get z is equal to 3. And if we do our check, that works. This is negative 14, so the inverse operation is to add 14. That makes a zero pair, and we get x is equal to 9. And our check, 9 minus 14, does equal negative 5, so we did it correctly. This one's a little bit tricky here. We have a negative y, and we don't want negative y. We actually want positive y. So you can solve this two ways. The first one is to subtract 3. and we get negative y is equal to 4. And if you divide by negative 1, you get y is equal to negative 4. This one we have negative 5 plus z equals negative 7. So the inverse operation is to add 5 to each side, and we get y is equal to negative 2. And to do our check, I didn't do the check on the last one. I'll do that in a second. Negative 5 plus a negative 2 does equal negative 7. And then in this one we have 3 minus a negative 4. So we get 3 plus 4 is equal to 7, and 7 equals 7. Here's a PAT question. So this is a balanced mobile. And it says, which of the following equations correctly represents the relationship between some of the objects shown in the diagram below? So a mobile, we know that the left side equals the right side. Otherwise, the mobile would be kind of unbalanced, right? And you'd have stuff hanging off at an angle. So we know that the left side equals the right side. And if you look for common items, well, this is the same as this, so that would be equal. And this is the same as that, so that's equal. So what we're left with is those things are equal. So that's going to be option D. And you've got classwork on page 4 and 5.